5.2 Scientific Notation and Rational Exponents. So if you're given a problem like this, 5.987, and they tell you to rewrite it in appropriate scientific notation. First thing we're going to look at, the decimal point is located in the correct spot. Remember, the decimal should always be between the first and second non-zero numbers. So it's already set up where the decimal is between the first and second non-zero numbers. The next thing I'm going to do is I'm going to count the number of numbers after it. There are 3 of them. That becomes your exponent. So we're going to write 5.987 times 10 to the third power. Next example, they give us 773.4. So again, 773.4. First thing, it's not where it needs to be. It needs to go over in between the 7 and the 7. So now we become 7.734. Count the number of decimal places. There are 3 again. So now we're 7.734 times 10 to the third power. Here's the thing about exponents. Moving big money, you're going to have a positive exponent. Moving small virus types, you're going to have a negative exponent. Because you have to think of these as being seen with a microscope. Next example. So in this one, they want us to take the problem that's already in scientific notation and expand it out to either decimal notation without using exponents or scientific notation. So first thing we need to look at, the exponent of this is a power of 2. That means it's the number of places the decimal moves to the right. So for this problem, it says 7.892 times 10 to the second. So it means 2 places. So this decimal point, which is at 7.892, you are shifting it 2 places to the right. So it becomes 789.2. That's because it's a positive exponent, we shift it to the right. On this next example, it says 9.18 times 10 to the negative second. When it's a negative exponent, it's the number of places the decimal moves to the left. So we have 9.18 times 10 to the negative second. So we have 9.18, and it's shifting 2 places. Because there's a place here that there is no piece, you're going to put a placeholder of a 0. So we end up being 0.0918. Next example. So on this one, it says they want us to evaluate negative of negative 16 to the 1/4 without using a calculator. So remember before, negatives inside a radical that has even root do not exist. So we have negative of negative 1/16 to the 1/4. These type of problems, when you're having fraction exponents, the bottom number of the fraction, that is called your index. The numerator of the fraction, that is the exponent inside the radical. So if I were to rewrite this, so here we're going to write negative And then remember, we said it's a fourth root. That's what the index value is. And we have negative 16 that's in parentheses raised to the first power. Right here, we have a negative inside. Even though there's a power of 1, means it's still just, this is the same thing as just saying negative 16. Negative inside, even root. This does not exist. Next example. Okay, so on this one it says parentheses of negative 36 to the negative 1/2 power. Okay, so negative 36 to the negative 1/2 power. Now, on these type of questions, if you have a negative exponent, there's a rule that says no negative exponents. You must make positive. So what you think about is flipping it over a value of 1. So first thing, I'm going to put a fraction bar line. I'm going to put a 1. And what does that mean? It means this entire thing is going to swap positions. So now we become 1 on top, negative 36, and now your exponent becomes positive. So now here, notice it says negative 36 to the 1/2 power. Well, that's the same thing as saying the square root of negative 36. In this instance, negative inside and even root, D and E. Now, I'm going to change this problem up without it and say negative 30, if we saw negative 36 to the negative 1/2 power. The difference between this one and the one that we started with, parentheses is involved. When you see something like this is the same thing as saying negative 1 times 36 to the negative 1/2 power. So we follow the same thing as the last one, put this portion over a 1 so that we can swap positions. You still have negative 1 times, now we see 1 on top, 36 to the 1/2 power. So we become negative 1 over the square root of 36, which is negative 1 over 6, a plausible answer. So the difference is parentheses, no parentheses. No parentheses, it means negative 1 times the value we see. Parentheses contains the negative, means it's inside it, attached to it. Next example. Okay, so in this one, they want us to add 2 scientific notations. So I'm going to show you 2 different methods on the calculator. First thing we notice is that bases are the same for these 2 pieces, but the exponents are different. And if we were multiplying, then all we would do is add our exponents, which is fine. But in this instance, we are adding the 2 terms. So in your calculator, on the scientific calculator or the graphing calculator, you have either the use of the caret key or the use of the double E key. So, and you're going to get the same answer either way. So what we're going to do is we're going to use the caret key for the first one. So you're going to do 8.8 times 10, hit the caret key, type in 16, close the parentheses, hit a plus sign. 2.1 times 10 caret 13, close the parentheses, and then hit your enter key. So parentheses 8.8, I hit times, type 10 caret 16, close it, plus parentheses 2.1 times 10 caret 13, close it, and it results in 8.8021 e to the 16th, which means times 10 to the 16th power. We're going to do the same thing using the double E key. So in order to do that, on your graphing calculator, if you look above the comma symbol, there's a little EE key, which means you have to use the second and then EE. So you're going to go 8.8, hit the second key, and then your comma, and then type 16 plus 2.1, again, second, the comma, and then 13, and close it. So you're going to go parentheses, 8.8, second, comma, there's my E, which means times 10, then 16, close it, plus, parentheses, 2.1, second, comma, 13, close it, hit enter. And again, we result in 8.8021 e to the 16th, which is 8.8021 times 10 to the 16th power, the same solution. On the next example, in this instance, they want us to multiply. So you're going to do the same thing. Instead of doing the addition symbol, you're just going to do the multiplication symbol between the two pieces. So I'm just going to use the EE key for this one. So we're going to go 4.7, the second key, comma, and I'm going to put a 1, times key, 2.1, second, comma, negative 31, close it. So we have parentheses, 4.7 second, comma, to the first, times, parentheses, 2.1 second, comma, to the now. The negative sign is not the minus key. The negative sign is the little negative piece down here, negative 31st power. Hit enter, and we end up with 9.87 e to the negative 30th, which is 9.87 times 10 to the negative 30th. Next example. So in this one, they want us to divide. So we're doing the same process, only set up as a fraction bar. So think of it as 3.036 times 10 to the 91st being divided by 3.3 times 10 to the 42nd. Now, normally, if we're fractions here, the decimal values, the bases are the same, you're going to subtract your exponent values. But because these need to be divided also, it's just easier to use the double E key. So you're going to go parentheses 3.036, your second, comma, 91, close it, hit your divide key, and then type in 3.3, second, comma, 46, and close the parentheses. So follow the example, parentheses, 3.036, second, comma, 91, close the parentheses, hit the divide key, and then put in 3.3, second, comma, 46, close the parentheses and hit enter. And it gives us a syntax error. So we were going to go to see where we didn't put a parentheses around here. So let me go up and hit second insert, a comma there, parentheses. Now it gives us our result, which is 9.2 e to the 44th power, which is 9.2 times 10 to the 44th power. Next example. So in here they want us to simplify the expressions x to the 2/3 times x to the 3/2. So let me write some rules down. When you have when it's talking about variables and exponents, you have base is the same, which means they both have a shared base of x. Bases are the same, you're going to add the exponents. So think of it as x to the a value times x to the b value. Since both bases are the same, we become x to the a plus b. And a and b represent numbers greater than 1, or greater than 0 if you want to assume it. So on this one, it says x to the 2/3 times x to the 3/2. So remember your rules. Bases are the same, okay? So I'm going to write x 2/3 plus 3/2. So here's the problem. Back in your younger days, we were not allowed to just randomly add the numerators and the denominators here. Bases are different. The fractions have different denominators, so we need to refer back to our LCD. So the least common denominator here would be a 6. So I'm rewriting it with a denominator value of 6. For 3 to become 6, I multiplied top and bottom by 2, so I become a 4/6. For 2 to become 6, I multiplied top and bottom by 3, and I become 9/6. Now we can add our numerators. 4 and 9 is 13 over 6. So if I were to rewrite it like this is what my final answer would be. So x to the 13th over 6. Yes, it's an improper fraction. 13 over 6 does not reduce. Now, it says it can be rewritten as 1 over xb. So if I want to rewrite this as a fraction, so let's look at it this way. I want to rewrite this as a fraction. So now place it under a 1 and make the opposite sign. So I'm a positive 13 over 6. I'm going to write 1 over x, negative 13 over 6. So the b value, the exponent is going to be negative 13 over 6. And here the exponent is going to be 13 over 6. They just want the exponent depending on the system you want. Next example. When dealing with fractions, as in division here, when dividing with like bases, you are going to subtract the exponents. So we have x to the negative 1/2 over x to the negative 1/4. Since the bases are the same, again, I'm going to write x to the negative 1/2 minus, and I'm going to put minus 1/4. Now, I put negative 1/4 in parentheses because it said minus, you're subtracting it. If I didn't, I would not see the sign change. Now I become x to the negative 1/2 plus 1/4. And now we're just going to apply the rules again. Denominators need to be the same. So I need to change it to a base of 4. So in order for 2 to become a 4, I multiply top and bottom by a 2, and I become negative 2. 4 is already there. So we become x to the negative 1/4. So if I'm in the form of xa, I have an exponent of negative 1/4. But if I want to change it to 1 over xb, remember that you're going to make it over 1. So watch your positions, and you got x to the 1/4, so I become now a positive exponent. On the next one, it has it in root form. Okay, so on this one, it has it as the 6th root of x times the 1/2 of the square root of x. First thing we need to do is rewrite in exponent form. So remember, the little number in the groove, our index value, this is the denominator, the denom. So we start out with the 6th root of x times the square root of x. That becomes the x to the 1/6 times x to the 1/2. So here, bases are the same, and you're multiplying, so it means we're going to add the exponents. So x to the 1/6 plus the 1/2. Again, denominators are not the same. So 6 and 2, common denominator will be a 6 for both of them. That one did not change. The first one, 1/6, is still 1/6, but for 2 to become 6, I multiplied top and bottom by 3, and I write 3/6. Now our exponents can add, so become 4/6, which happen to be reducible. So 4 over 6 reduces to 2/3. And that's what our answer would be. Now, we left it here in exponent form. So if it wants it in exponent form, this is what you want it in. If they want you to change to radical, the 3 is your index, the 2 is your exponent. So if I wanted to change it to radical form, then I'm going to write the cube root of x squared. So depending on how they want your answer, there's your 2 different methods. Next example. So on this one, they wanted us to divide them. So again, first write them in exponent form. So I would become y to the 1/3 over y to the 1/4. Remember, if you're dividing them, you're going to subtract exponents. So we're going to write y to the 1/3 minus, and I'm going to put 1/4 in parentheses just in case it happened to be negative to begin with. So now we're going to see denominators are not the same. Common denominator of 3 and 4 would be a 12. For 3 to become 12, I had to multiply top and bottom by 4. For 4 to become 12, I had to multiply top and bottom by 3. Now we can do our math here. So 4 minus a 3 results in a 1/12. So here's our answer. If they wanted it in radical form, remember the denominator is your index, so I become the 12th root of y. Dependent on which method they want, there's your two possibilities. On the next example, they want us to distribute y to the 5/9 times y to the 2/9 minus 4 times y to the 3/9. So there's a method I call the box method. And maybe in previous courses you saw it or whatnot. So y to the 5/9 is one of your pieces, and then you split your parentheses pieces into two terms. So I see y to the 2/9 minus 4y to the 3/9. And this just makes your math organized, so you can do the math per piece. So now, because we're multiplying, remember there's a multiplication dot, imaginary, we don't see it. You're multiplying, your exponents are going to add. Because we're multiplying, your exponents again are going to add. Now, since the denominators are the same, those terms add easily. So it become y, 5 plus 2 is 7/9. Minus sign, because it's a -4. Y, since the denominators are the same, 5 plus 3 is an 8/9, and there's your result. Next example. Again, you can apply the box method. In this term, we have two terms inside this parentheses times another two terms. So we become a 3x3 grid is what we're going to do. So I'm going to put multiplication dot in the corner. We're going to be x to the 1/4, positive 6. I also keep the signs of if it's positive or negative, just in case the sign changes. And we're going to apply the same thing again. So x and x are the same bases, so I'm going to add my exponents. Since these two are just there, we're going to slide them together. Slide these two together. You think back in your old days, you may have done lattices, and this is the same setup. And 6 times the 2 makes it a positive 12. So the one thing we know is if you look diagonally are usually like terms. So diagonally, usually they're like terms. So now let's look at the thing. X 1/4 times plus 1/4 makes it x to the 2/4. And I see 2x to the 1/4 plus 6x to the 1/4 plus 12. We can see that these two right here have the same attachments. Their coefficients are just going to add together. This one, 2/4, is the same thing as saying 1/2. So it will become x to the 1/2 plus $2.06 makes it 8. X to the 1/4 plus 12. Next example, actual last example, says factor the following expression, write the expression using rational exponents. It says 5x to the negative 1/7 plus 2x to the 6/7. So first thing, 5x to the negative 2/7 plus 2x to the 6/7. So we need to find out a common piece out of both of these. So first thing, I know they both share an x. The denominators are the same, 7s. Fractions are different, but I can pull out 2 pieces out of that 6 piece. I can factor them out. So we're factoring out x for both of them. Now, if I wanted this to be a regular piece, if I divide by -2/7, that's what we're factoring out. -2/7 out of both of them, because I don't like that negative exponent. So we become x to -2/7 on the outside. That cancels out, leaving you a 5, 2. Now here, I am dividing it out. If I'm dividing it out, the rule of fractions say that we subtract our denominators. We subtract our denominators. So 6/7 minus a -2/7 is how you have to treat it. So it becomes 6/7 plus 2/7, becoming in 8/7. So this is going to be 8/7. And the reason being, if I were to distribute back in, that's how you think about it. -2/7 times an 8/7 means they add together. So -2 plus an 8 makes it a +6. So not only does it have to work distributing, but you have to be able to reverse engineer it. So this would be our factored piece.